Okay, let's begin. I just want to say one thing. I don't know whether you all are aware, your homework, you can, I think I've mentioned this, just a reminder, you can have multiple attempts. Well, officially there's 100, but I don't think you run out. Also, the score gets transmitted to Moodle, but it's not immediate. So it takes a couple of minutes actually sometimes. So just bear with the system. But if you make a mistake or if your points are not full, I actually encourage you to go look at why. Especially homework zero, if you did not get full points, you need to check why because it means that there's something about the calculator that you may not have understood. So it's important to go through your homework zero that I think just closed. Yes.
Oh, I was just gonna ask if there was a way to know which answers you got wrong.
That's right. So the software does not, unfortunately, allow me to tell you which ones you get wrong. So the only best compromise I have is you have to check your score with Google and see. Now, I know it's frustrating. I understand, but there isn't any way out because I've tried to play with it. It's not possible to say, tell me what's wrong for some questions, but some not. Because there are some I give you multiple choice. It doesn't make sense for me to tell you, oh, you got that wrong in that sense, because then, I mean, for example, if I gave you a true false test and I told you which ones were wrong, then what's the point? So, but I understand. So the numerical questions, it would be nice to know it's not correct, but I cannot somehow do it the way the software is. So all I can say is the next best thing is you check your score. Don't guess, I would say, and document your work. If you are trying to check your work, I would say new for word problems, you just maybe shut it down, come in again another day or something like that. And try not to look at your old answers because you are very influenced by what you've done. But for numerical calculations, it's actually quite easy. If you do a problem, don't look at your own work. If especially the complicated computations, right? Try to redo it like from scratch, because it can be the case that you were. Because I've had a student who asked me like, what? So what happened was sometimes doing the problem again and again results in the same answer because you are actually doing something which the calculator thinks you want, but it's not the correct notation. So it's not that you're doing things inconsistently, but you are consistently putting in something that the calculator thinks you want, which isn't correct. You know what I'm trying to say? So just check your work. And if there's anything you don't understand, come to me. Now, I just want to revise this applet thing that we introduced the last time. I have introduced this basic coin tosser for a reason. It's a bit easier to use. There's less going on. So I just want to reiterate. Do you remember the dolphin experiment we talked about last week? Right? So buzz. So this number is not really important, but it's important for this class. Does anyone remember the score the dolphin got correct? Do you remember the setup? The dolphin has to press one of two buttons, and each time it's just two buttons. One is correct, one is wrong. So how many tries did the dolphin do this, and how many did the dolphin get correct? Does anyone remember? I mean, it's not super important, but does anyone remember the statistic? Yes.
Yeah, 18 tries.
Okay, you have the one less than the full thing going on, but it wasn't 17, 18, but it was just very close. Does anyone else remember what was the statistic involved? Yes. Okay, well, all of you are off. Okay, it's 15, 16. It's not a big deal. It doesn't matter. So, but thank you. So there were 16 tries, correct 15 times, basically. So how do we check the whole objective of statistics, and that's where we're going to do what we're going to do for the whole class, is we want to evaluate how special something is. How rarely does it occur? That's the main point. And to do that, we model it using a coin tossing model. Now, because the dolphin only has two options, that's like a true false test. I try not to talk about dolphin very much because it's less, you know, relevant, I think. So I don't want to dwell too much. I transform the dolphin into you, basically taking a true false test. Now, if you did a true false test with 16 questions, how likely are you to see 15 correct if you guess? The if you guess part is very important. We know common sense tells us it's quite unlikely. That's why you study for exams. I mean, that's not the reason why you study for exams, but it's part of the reason. right? You study so you don't guess. But if you guess, you can get really, 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 really lucky and get 15 out of 16 correct. But the point is, we know that happens rarely. How rarely? That's what this coin tossing is doing for us. So you need to change 10 to what in this scenario? Change 10 to 16 because you're trying to replicate the study. Keep this, change this to 1. This rows means do one set of 16. Just do one set of 16. And this prop head, what do I need to change? Do I need to change anything? Does it stay at 50%, 0.1? It does, because this is a true false test. So you go to 16. And let's just not overtax the system and just ask for 1. Right? So see, in this case, I had a pretty rare result. I had 4 heads only. A fair coin, 4 heads. I mean, this could happen. But the point is, you do this many times, then you plot the graph, and you see how rarely these things happen. So let's immediately go to the applet now. This is the applet that we are going to use. Not that one, because this is URL for applets. It's also on Moodle. This is better suited. This was created much more recently, so it's much faster. The other one is 1998, honestly. So don't change probability of heads. That's 0.5. What's the number of tosses now? Not 5, but this is identical with the other applet. 16. You're trying to replicate the study. So this is 16. Number of reps. Okay, this one is fixed. Always we do 1,000. You need to repeat something at least 1,000 sets of 16 to get some kind of long-term trend of what's going on. So change this to 1,000 and then just draw samples. Does this graph surprise you? Right? This graph tells you what? This is what happens when you toss a fair coin. Wait, the 0.5 is up there. When you toss a fair coin, 16 times. Most of the time you get what? 7, 8, or 9 heads, which makes perfect sense. So the only twist here today is I'm going to teach you, we're going to finally answer this question. How likely do you get on a true false test a score like 15 or 16 when you guess? So even by eye, you can look at this picture. Were there any simulations at 15? Sometimes this plot is not so intuitive because there might be one dot hiding there. The way to check formally is and pay close attention. Go to this box. Do you see a count box here? You put 15 in because that's your result, and you hit count. So our eyes did not deceive us. Did we have any? Okay, so I want to explain a few things to the class. I hope this is not true of this class. It is true of some of my students from former years. That the moment there's more than one number on the screen, they tune out. They can't. I just because I can't even, right? I can't even. When they see more than 2 numbers, they just get mixed up. Don't be that one, okay? It's not hard, but you have to pay attention. This number tells you that there were no simulations that were as extreme as 15. Sometimes there's one little dot hiding there. It doesn't show the picture. Then it will say 1 in 1,000. So a few very important things. This means in 1,000 simulations or reps, if you like, in 1,000 replications of 16 horses, each replication is 16 horses, I never had a result like 15. So is it rare to get 15 out of 16 on a true false test when you guess? Not when you study, when you guess. Yes, it's very rare. It didn't happen in 1,000 tries. Now that's very important. So this number here is of course related to this, but they're not the same thing. Some students think that this number and this number are somehow the same. How can they be the same? How can 0 and 15 be the same thing? It makes no sense. So numbers are there for a reason. The red line is there for a reason. It's to indicate the important position of what the original score is. See the center? Now, I'm going to teach you something from the start. I want you to do. Whenever you use this effort, once you have put in the number of, I don't know, correct trials or whatever, the 15 thing, can you make sure you change immediately to proportion mode? Do you see a small button here? Now, I want you to pay close attention to the x-axis. What happens when I click proportion? In fact, what happened to the 15? Did you see that? I'm going to click this again. Go back to this one. Did you see something's changing? Can anyone tell me what they think 0.9375 is? What's 0.9375? Does anyone know? Why did 15 change to 0.9375? Anyone know why? Yes, correct. 0.9375 is 15 out of 16. Why? Because you asked for a proportion. That is why from the start, I want the class to distinguish 15 is a count, but 15 out of 16 is a proportion. It's a proportion of fraction. This was in the proportion of fraction. Again, I notice students have, there are some misconceptions students have. I'll share this one with you. Um, not all, sorry, when I say something is a fraction, something that's stated as a decimal representation is a fraction. 0.23, for example, is a fraction. Okay, even though it doesn't look like a fraction, it is. Just bear that in mind, okay? Maybe that's because I was wondering why some of you were answering the question, is a proportion a fraction? You said no. Just because something is written as a decimal representation doesn't stop it from being a fraction. That's the point. It's equivalent. Anyway, so this is because this is 15 out of 16. Good. Did you see that when I change the proportion, even the whole axis changed to a proportion? Right? You don't see 15 and all that anymore. Everything is converted to proportion. Even the word number of has changed to proportional. That's one thing to note. The other thing is, previously it was centered at 8, right? Now it's centered at 0.5. Why is it centered at 0.5? Should it be centered at 0.5? Of course. Because when I set up the simulation to take place, I said I want the probability of heads to be 0.5. If you make the system simulate with a central probability of 0.5, of course, most of your simulations are going to have proportions that are centered around 0.5. So it doesn't surprise us. Now, I know proportions are slightly less intuitive than counts. Yes, I agree. But it is very important from the start that you always use proportions, because I will show you what happens next time if you don't. Because there's a number that gets displayed that's wrong, or it's the wrong one to use if you're not in proportion mode. So we start with counts, but we quickly graduate to proportions. So 8 out of 16 is 0.5. Okay, so that's what's going on here. So let's go look at our slides for a bit, and we will go revise some of the things that we talked about. All right. So we have done this slide. Okay. One way to assess whether an observed score is typical or atypical is to look at what happens when you simulate many times under a hypothesized value of the long run proportion. When you simulate, you need to set your coin to have a certain probability of heads. It's not always 50%. In the case of the dolphin or true false test, it is 50%. We will talk about this when I give you a written sheet. Again, right? True false test have only two options. If you guess, there's a 50-50 chance. So that's why the heads probability was 50% in this example. But typically, you can set it to something else depending on the scenario. If you've done your homework at all, didn't I give you one that said that there's a multiple choice test that you take and you guess? How many options did I say the test had? Was it 5? Actually, I've given so many homework that not so many homework. So I've given different homework. I think there's one that I say 4, there's one that I say 5, or something like that. The earlier homework things, right? But basically, the point is you need to look at each setup separately. If you take a multiple choice test with 5 options, A, B, C, D, E, then what is the long run chance that you get something correct? If you guess. If there are 5 options for every question in a multiple choice test, then in the long run, if you guess on all the questions, what is your long run proportion correct? 1 in 5, good, which is 0.2, 20%. In that case, if you're trying to replicate that study, then your hypothesized value of the long run is 20%. So it's not always 0.5, all right? So you use an applet to do this, and we've talked about it. So the two dolphins are the case. We consider what are typical scores that Buzz would get if he was guessing. The claim that Buzz is guessing is equivalent to saying that the long run proportion the dolphin gets it correct is. Does anyone know what the answer is to this question? When I say you guess on a true false test, what am I actually saying? When I say that you're guessing on a true false test, I'm saying that in the long run, you will get how many percent correct? 50%. Good. They are one and the same. Right? So if I say you are guessing on a true false test, it is the same thing as saying that in the long run, you will get half correct. Now I'm going to ask you a question that's going to sound quite strange. Why do I prefer you to say half or even decimal 0.5? Why do I not like you to say 8 out of 16? Does anyone know why? I mean, I know numerically 8 out of 16 is half. I'm not saying it's not. But why is half or 0.5 a better answer than writing 8 out of 16? Does anyone know what I'm getting at? Yes.
Maybe because it's just a probability question.
I think you're on the right track. Basically, if I say 8 out of 16, it kind of cements in people's mind that I'm only going to try something how many times? 16 times. Now, is that long run? No. So this is a very fine point. It's not wrong to say 8 out of 16, but it is misleading, I would say. A little bit misleading because it means you don't fully understand what a population is. Long run is long run. It means there's millions of potential questions. If you guess on a million questions, you get about 50% correct in the long run if you guess. That's basically the point. All right. Can you give me some typical scores that you get if you guess on an exam true false test with 16 questions? Can anyone just give me fractions? What out of 16 would be a typical score if you guess on a true false test with 16 questions? Anyone? Okay, 6 out of 16. Anything else? 7 out of 6. Yes, these are all very typical. Good. When you guess on a true false test, these are scores you could certainly see quite often. Can you give me some that you would not often see on a true false test with 16 questions when you guess? 16 out of 16. And can you go extreme the other way as well? Yes. What? Yes. Now, somehow in my slides, I wrote all extreme large. You can add some extreme small. Please do that. Okay? Extreme can go either way. So you might also see 1 out of 16 very rarely if you guess on a true false test. So how do you quantify how rarely something is happening when you guess? You toss a fair coin 16 times. Why 16? Because the study involved 16 tries. Your experiment, your coin flipping, is trying to replicate that. All right. You toss a fair coin 16 times, and you record how many times you get a hit. Repeat this many times. You can put in brackets. 1,000 is our favorite number in this class. You do this 1,000 sets of 16, and each time you see how many hits you get. Plot on graph. Then draw a red line at 15 to see how many cases are like that when you simulate. That's it. So you can take a picture of this if you want. There's a fair bit of copying, I realize. But please go home and complete your notes. Okay? So I want to do a worksheet, but I've been trying something where before I even give you the worksheet, I want to do it on Scratchpad first with you on a very similar problem. So let's do the dolphin thing in a very careful, with a very careful consideration of what's going on. All right. Okay, first of all, let me get the class. So this is section, I need to, sometimes I lose track. What section are we? This is section 11. All right. Okay. Okay, this is here. And I am going to paste what I want to do with you right now. So I want to do, yeah, this one. Okay. Ugh. You know, I realized something. There is an invisible table here that I absolutely cannot delete. If someone can do it, can you teach me how? Google Sheets is not allowing me to delete stuff. No, sorry. If someone can clear this space, please tell me what magic you use. I can't. I can't display it. I can't get rid of it. It's just empty space. But the Okay, all in good time. If you discover, you let me know. All right? It's these things just bug me like crazy. Okay, so Buzz had 16 attempts at pressing the correct button. Here is his test result. Now I made this up. We actually know he got 15 correct. I just put the wrong one at attempt number 3. That's not so important, but there's one wrong attempt. Correct, correct, wrong, correct, correct, correct. Oh, okay. Write this proportion correct as a fraction and also a decimal and give me the symbol. Now, I know for some in this class, there's always a wide range of abilities. Some students really get these things very quickly, but I'm repeating things many times because some do not get it as quickly as others do. So can you humor me, tell me, what is the fraction correct? Convert it to a decimal and give me the symbol that we use for this fraction. All right. If you get CCW, CCCCC, what's the proportion correct? Give me as a fraction first, then convert it to a decimal, and then give me the symbol for this fraction. All right. That's right. So it's 15 out of 16. Good. Which everyone with a calculator, actually, do you know, you don't even need a calculator if you can remember what we talked about 5 minutes ago. What is 15 out of 16 as a decimal? Do you remember? The computer did it for us, actually. 15 out of 16 converts to what as a decimal? 0.9375. Good. What's the symbol for this? Either this or this. We have the same. What's the symbol we use? What kind of thing is 0.9375? And we have not introduced many symbols yet, so we are still at the beginning stage. What's the symbol for this? You don't need to actually give me the symbol. You can say it in words. We'll do it. It's faster that way, right? 0.9375 is called.
Isn't it p hat?
It is. Is it not typing now? Wait, is there something wrong with Google Doc? Because I don't see anything appearing at all. Is it not possible to type anymore? Did I lock it? Okay, no. So what is this answer? All right. Give a symbol for this sample proportion correct. Then you can spell it out. You don't need to actually give me the symbol. It's just easier to just spell. Do you know how to spell here? I mean, do you know how we write it? Seriously. Yeah, you don't have good. That was good, but you don't need to give me the symbol like that. You can spell it out in words. All right. You can say yes. So it's p hat. Good. Oh, that didn't take long at all, right? Okay, so p hat, right? You just say PH80. Don't. It's not a big deal, right? Okay, yes. That took like 5 minutes. But I'm so glad no one said pi. That would have really made me upset. Why is it not pi? Because we know that pi is long. Right? What? I mean, it's pi a fraction. We're going to say things about pi, but it's not pi here. It's p hat. Because you observed it. Good. So you know what I used to do in previous classes? If you like using p hat symbolically, you can do this, but be very, I don't know whether to introduce this. You can do a header for the document and stuff all these symbols in the header. So if you want to go to the header and pull up. The problem is when there's a header, I've had students who paste answers in the header and the header gets huge. So I don't know, use responsibly. I don't even know whether you want to have a header or not. So just say PH80, that's fine. Okay. Define the process population here. I'll give you some help. The population is, I hope you realize it's an abstract one. It is the collection of maybe I'll say entire. It is the entire collection of all possible answers on a true false test. So if Buzz does not know what he's doing and guesses on every attempt, what does it look like? Now, if you guess on a true false test and you do many questions, all true false and all guessing, can you give me a string of C's and W's that you might see? Someone try? Now, yeah, thank you. Now, you see, if you don't know what to do and you guess, you should roughly have a 50-50 mix. Very good. Of C's and W's, right? Maybe you have a lot of corrects first and then you get wrong, but in the long run, you should see about 50-50 because you're guessing. Don't forget, if something is a population, what's the symbol we use? You put like that. Can you give me a sequence of C's and W's that you might see if Buzz the dolphin is actually smart and knows what he's doing? Just give me one. What should you see? Should you see an equal split of 50-50 CW, or what should you see? If you know what you're doing, you should see more C's than W's. Does it make sense? Okay. So I'm doing these things to help you see what the population is. It's not that abstract. It's binary. Like, okay, so every statistical test starts from a hypothesized statement about the parameter. Remember, we don't hypothesize about the statistic. There's no need. You know what the statistic is. You make a hypothesis, a status quo original statement about the parameter from the start. When I say you guess on a true false test, I'm actually saying that the long run proportion you get correct is, can you give me a decimal? When I say you guess on a true false test, what am I saying? I'm saying that in the long run, the proportion that you get correct would be, you can give me a decimal. Actually, I prefer a decimal. I'm saying yes, which is 0.5. Good. That's what I'm saying. Good. All right. The applet generates many samples of size what? Now we are doing the dolphin study, so we should do how many tosses each time? Not reps. Every time you do a sample, what should be the size if it's the dolphin problem? Good. Of size 16 and calculates the proportion correct each time. All these are simulated under the status quo assumption that the dolphin is guessing. See, all of statistics must start somewhere. We always start with the guessing hypothesis. You know why? When you assume someone is guessing, does it give you a simple number for the hypothesized value? 50%. Notice we don't start from the standpoint of saying the dolphin is smart. Yeah, how smart? If you say the dolphin is smart, okay, tell me what the long run probability that your test is of getting correct. You know the word smart is arbitrary, it's subjective. But when you say you guess, that enables you to start at the benchmark and say, okay, when you guess, I know in the long run you should get 50% correct. Let's see what happens when you guess. See, that's very, very important. So the plot shows all the simulated proportions when you guess. Did we see this picture today already? Let me flash back to the applet. So as I said, I've tried to teach this in many ways. And to my chagrin, that's the word I want to use, there are students who never understand. Even though this is introduced literally in the beginning of class, there are students who never get it. So I've tried so many things. This is the first time. I'm using colors now because I don't know how you learn with sound. I don't make TikTok videos. Maybe one day I'll start having to do that. But I'm using colors now to help you because there are students. I don't be surprised. I hope no one's like that here. I've had students when they see 2 or 3 numbers on the screen, they zone out. They cannot. They can't. They just cannot. The numbers are drawings to them. They have no meaning at all. That's a dangerous place to be because even if you don't like math, even if math's not really, a little bit of number facility is a good thing to have, you know. Don't be proud of the fact that people say, you know, I'm very bad at math. That's not something to be proud of. Okay. I know in America, the culture here is a bit different. You can say things like I'm very bad at math, and This kind of statement doesn't fly elsewhere, in the rest of the world. Being bad at math is not seen as a virtue anywhere else. All right. So anyway, the point is, I'm using color coding to help you. We will try to maintain a blue color for the center of the distribution and the red color because it's so important to be the observed statistic. So can you tell me, without looking at my applet, where is the plot center? Give me a proportion. Don't say 8. Where's the plot center? Yes, it is always centered at the status quo hypothesized proportion. You know what? What will help the class? Can you color this blue? Right? Go find the blue or highlight it blue, but I don't care. Right? Can anyone tell me what was the number where the red line was? Give me a decimal. Does anyone remember? We have talked about this. Sorry, what? Where was the red line positioned? Why is this so important? The red line, yes, 9375. Remember that famous 93? What is 9375 is the score that the dolphin actually got. It is so important that we put it as a red line here. Now comes, I ran out of colors, so I use purple now. There are some red dots after this. What do the red dots on the right side of the red line indicate? They are simulated proportions which are greater than what? Can you fill in a number? The red dots after the red line are simulated proportions which are greater than, very good. Now, we are in proportion mode. Can you just put a stroke, a slash something? These are proportions that are greater than, let's use the decimal, 9375. That's what a graph is. This is a number, and these are things bigger than that number. Okay, finally, there is one last number here. Remember there was a number floating on top here? If you remember. That is to answer the final question. This means when you guess about how many percent of the time you get a result at least as good. Okay, to answer this, I'm going to have to show you this. Do you see that number floating there? It's so important it gets repeated here as well. Did I ever see a score as good as 0.9375 when I simulated? No. Therefore, can you now answer this question? About 0% of the time. Good. You will get a result at least as good as, and this is a repeat. Kind of a trick question, 9375. Good. So I want you to stare at the graph and really, really, really internalize what I'm saying. There are 3 numbers of interest. There's going to be a 4th, but not today. Right? I'm going to give you a green color when that comes out, not yet. All right. For today, center is here. All proportions. Proportion. This axis is the center proportion, observed proportion, and then there's a number floating on top. That one is not this. This gives you the fraction of simulations that happened that are as or better than what you got. Okay, so with this setup, I'm going to immediately give out this. Just pass it down to the back, okay? And give this a try. Make sure your names are on the sheet. So do page 1 first, then do page 2, and we'll discuss it together. After you're done, we will discuss it so that we can see you're on the right track. You will see what I've done is I try to give you very similar questions to the dolphin. Do page 1, okay?
Yeah.
Okay, to make it seem like the dolphin all over again, I'm saying you take a true false test with 60 questions. Here's your result. Okay, first, tell me what the fraction correct is. So just write your answers out. Later, when you're done and happy with yours, I would like it for you to contribute to the scratch pack. You'll get a group or so to do that. All right, but you do it on the paper first.
Yes. Yeah. Oh, let's be that.
Also, can I ask, when you are done with your work, can someone post a screenshot of your applet? I'm not going to put this picture anymore. Can you put the applet that you use? Because you need to use the applet to tell me what's the percentage that this happens. Can you show me a screenshot of what you've done for this scenario? And when you do your screenshot, can you make it of the whole thing from the places where you must put in the 1000 and all those kinds of things, everything basically. Also, make sure you are in proportion mode with the red line drawn when you put your screenshot. Okay?
Yeah. Yeah.
If you are smart about it, some things are repeated, right? It's, the scenario has hardly changed on the dolphin, only the result has changed.
Oh, yeah. So you know what you're doing, destiny. Yeah. Oh, yeah.
Okay, I hope most of you are already towards the maybe 4 or 5. When you do your simulation on the applet, don't use that ancient one. Use the one I just showed you. Someone can paste their screenshot here, all right, and we can talk about it. All right. That's awesome. Can you whoever posted this? Can you do this? Is correct, but can you show me the screenshot of everything from the the top left northwest corner of the screenshot where you are the what number of courses? I want the class to see that as well. This is correct, by the way. All right. Thank you. Okay, I think we should be able to do this together as a class. Can I have some of you start contributing? Right? Write this correct proportion as a fraction. Can I have a fraction, please? What's the fraction correct? 14 on, yes. What is this as a decimal? Okay, this one you have to check your calculator. I can't do this in my head. Right? I can't. Some people can, right? I cannot. Right? What do you get? What is 14 out of 16? 8, 7, 5. Thank you. And I saw that number bouncing around, so I think that's right. So 875. Good. What's the symbol?
Yeah.
Yes. See, I don't know whether you have any other professor in this college who honestly does such incremental work. Do you realize how similar this is to what I just did? It's like 99% same. I don't think other professors are like that. I don't expect students to make any leaps, I hold your hand. Right? So, yeah, good. Right? We'll take it slow, as I said, because the rest of the course is very repetitive. Define the process population here. Does anyone want to try? You can actually copy paste. Isn't it almost identical to what I just typed? It is the entire what? So somebody can go copy paste. I don't mind. Actually, I encourage students to do that because it means you know the entire question of all possible answers true. Yes, good. And then is this the same? If you don't know what you wow, that was very good, very fast. If you don't know what you're doing and guess, you would expect above a 50-50 CW spread. And if you know what you're doing, you should see more CW. This is perfect. But do you realize this is why we don't use this as the status quo because it's vague. Yeah, how prepared are you for the exam? You see? All right. So statistical testing always starts with a hypothesized status quo statement. And so if I say you guess, I'm saying that the long run fraction you get correct is give me a decimal. If you guess on the true false step, yes, 0.5. Great. Good. This applet generates many samples of size 16. Why? Because I told you there's 16 questions on the test. They're trying to replicate that. Good. So we also have a very good sample of what you should have done. Probability of guess is 0.5 because this is the true false step. 16 because there are 16 questions. 1000 because we like that number for repetition. All right, 1000. Here's your picture. And everything is correctly done. See if this is in proportion mode. See, there are things about being a Mac user that are different from Windows. See, Macs, they have this extra circle around to make it even clearer. Windows doesn't have that. Oh, wait, does it? Let me see. It's just not, it doesn't stand out as much. Okay, but never mind. The point is, you must be in proportion mode. That's very good. Is it clear why it's centered at 0.5? Isn't that the process that you're starting from? You're saying status quo is 0.5. Why is 875 highlighted here? Because it's your score on the test. Okay, so let's see if this was answered correctly. Oh, this is very good. I'm so glad somebody else contributed, and this gives me a chance to say something. Did you see that this person's answer is slightly different? This person had 2 cases out of 1,000 getting a score like that. The other screenshot had 1. That's why we say this way of finding out the fraction of times is approximate. But you cannot get a situation where you have 100 cases out of 1,000 cases. Then the effort is broken, right? But they are in the same ballpark. That's the point. Good. And on the exam, you will actually not use the applet yourself. I will give you a screenshot so you answer based on the screenshot. You understand what I'm saying? All right. So let's pick screenshot 2 to answer because they're different. We'll go with 2. because it gives something a little bit more exciting, I would say. So I'm going to copy these questions. And I want you to change. Don't copy that table. Don't. Don't. All right. Let's base our answers on, okay, good. The table's not there. Okay. Where's the plot centered? Do I need to change it? Is it still 0.5? The plot is centered at 0.5. Good. Nothing needs to be changed. But where's the red line located? Can you give me a decimal? Change the 9375 now to 875 because you got 14 out of 16 correct. Okay. Yes.
So on question 3 and 4, it says that we're doing the proportion of if we are guessing and we don't know what we're doing, but then the graph doesn't show that because the red line is located at 0.87.
It's a very good point. The graph shows you two things. That's a very, very good question. So I want to clear this up. These are results you get. All these 1,000 dots are results you get when you guess on a true false test. But the red line is your actual scoring. Did you do a true false test 1,000 times? No, you didn't do that. You did the one test. The red line indicates the actual thing you got. But these dots indicate what happens if, in theory, you run a true false test and guess 1,000 times with 60 questions. Is it clear? That's a very good question. In other words, this is reality. This actually isn't. This is simulation. Okay, very good. That's a very perceptive question. Good. All right, so that's why it takes time to. And so, what do the red dots on the right side? They indicate simulations which are greater than the thing that you actually got. And this means when you guess about, okay, this gives me a chance. You either say 0.002 of the time. If this is a small point, but what is 0.002 as a percentage? If you want a percentage. That's right. If you want a percentage, you say 0.2%. If you don't like it, you know what? I'm going to give you the option. You answer it your way, right? Okay. You know, like the candy Twix, pick a side, right? So you pick an option that you like. So I don't care. Okay, make up your mind. But just know that if you want to convert to percentage, it's just slightly more tricky, but it's good. That's it. That is it. Now, can you flip the page over and do the other side? The other side is now saying there are 12 questions on a multiple choice test. Each question has 5 options, A to E. Only one is correct. So this is a slight variation to a true false test. I am confident you can. Right? Again, I'm going to start to paste this on Scratchpad. And when you are ready and you have written down your answers, I would appreciate it if you contribute to the Google Doc. Do you notice something? I will point it out. Although this is a multiple choice test, do you realize I didn't write A, B, E? I'm still focused on a binary result. Did you get the question correct? Do you see there's a subtle thing there? I'm not interested in what the actual answers are. I'm just interested in whether you got it correct or false. The point is, don't give me a string of A, B, C. It's still correct or wrong. All right? So I have opened up a homework 1B. My advice to you is when today's class is still fresh in your mind, the soonest opportunity you can have after my class is to do the homework because it is very closely related to today's class when your mind is still fresh. That's the best way to benefit. Don't I know it's due in a week, But don't let it sit there and stew, and then you open it 5 days from now. The soonest you do it, the better. Trust me. All right.
Yeah, we can do that. Oh, yeah. Yeah, so, all of a sudden there's five. So, start with that. Five. Yeah, okay. And then.
Well, since I bring up but this is their five options, but there's five.
Yeah, we can do
Here,
Oh. Oh, yeah, it would. Yes, yeah. Oh, but this one says.
No, it's
This is going not that would be. This way. Yeah. Wait, we're down here. Yeah. Yeah. Because this is the overall hypothetical. Oh, yeah. Okay.
Same deal. Whoever does the simulation, can you paste the whole thing, all right? From the northwest to the southeast of the picture.
Because it's so small. Why? I actually. Oh, I thought it was the same. Okay. No, I think it probably. Okay. No, I wanted. Yeah, and I do think. Okay.
Oh, this is so excellent. Thank you very much. Whoever did this, thank you. All right. This is cool. I've never seen this before. This is an actual photo of your screen. That's great. Please don't erase it. This is the first time this has happened, honestly. In my many years of like, what is okay? No, that's great. Thank you. No, and, statistics class is not the most exciting thing, I agree. It really isn't. So small things like this, I'll take it. And good. Okay. I think most of you are kind of ready. Can we start contributing to this? Thank you. So what is your own test result? CCW, CCC, CCW. What is the proportion correct? How many questions on this test? Wait, was it 16? No, it wasn't 16. 12, right. So it's 10 out of 12. That's right. Good. What is this? What does this convert to? Something a little bit ugly, I think. It's not going to be an ending decimal, so you can cut it off after 3 if you want. Right? Yeah, good. Or 4. That's our class. We try to send like 4 DP, okay, in this class. So 8, yeah, good. DF. It's good when the professor can't even finish speaking and answers appear. That's great. They keep it up. Yeah, I speak pretty rapidly and I couldn't even get the words out yet. That's good. Now, define the process population. Isn't this kind of the same thing again and again and again? Just copy paste. The entire, okay, but it's not true false test. It's now on a multiple choice. And you got to be more careful with how many options per question. The entire question of all possible answers on a multiple choice test with 5 options, something like that. Good. Okay. If you do not know what you're doing and you guess, okay, this one I'm interested to see. You should see a string of C's and W's. What do you see? Right? This is a multiple choice test with 5 options and you are guessing. roughly how many C's should you see and how many W's should you see? Roughly, if you get. I like it. Okay, again, yeah, you should see far more W's now than C's. In fact, roughly, how many percent should we see? Roughly 20%. That's right. And don't forget, very good. The dot. Okay. However, if you know what you're doing, this is vague. If you know what you're doing, this is always standard. If you know what you're doing, you should see more C's than W's. Very good. But you see, it's vague. How much do you know what you're doing? That's why statistics does not start hypothesizing about this. You make a hypothesis about this. This is concrete. And you guess in the long run, 20%. All right. So this single testing some sense. Okay. This means that the long run proportion you get correct is, can you give me a fraction, the decimal, right? When you take a multiple choice test and you guess and guess and guess and guess, in the long run, what should you get correct? The fraction you should get correct is 1 in 5, which is of course good. Very good. I notice a lot of students, this is not wrong. A lot of students like to say 0.2 well is 0. Somehow I can't do it because I'm scared people won't see the dot of I don't do this, but a lot of people do. I somehow have to write a 0 in front of it. This is not wrong. And it just triggers me slightly. It's not wrong. I don't know why. I can't do it, I cannot write dot 2. I just can't. Okay. The applet generates many simulations of size. Yes. You always reflect the original study. 12 questions. And you calculate 7%. All these are simulated under a certain status quo. Guessing, okay? So all simulation is done under the assumption that you are guessing. Status quo holds. Okay, and here we have this picture. In fact, we have two, and both of them. All right, let's answer another one. Okay, good. See, everyone's getting the same thing, which is fine because, in other words, the score you got, what does it mean? The score you got is so good, you cannot get a score as good as this when you guess. Now, it's not saying it's impossible, but 1,000 simulations doesn't even make that happen yet. See? So let's, okay, so just highlight a few things. Oh, this one. Okay, this one has, okay, I think I will just talk about this one. There is one thing not correct about this screenshot. Let's see the other one. Okay, this one's correct. Can anyone find out this one's correct? But this one is not correct. Can anyone find the error in this? Yes. That's right. That should be 0.2 because this is a multiple choice test with 5 options. But because the score was so extreme, you see, it's not reflected in this. However, if you put 0.25, you find that it's centered at 0.25. So I'm going to just take this away, but thank you. This gives me the chance. That is why I want to check. I want to check whether you know what numbers go to. See 0.2 and 12 and 1,000. The 1,000 doesn't change, right? Then you get this area and proportion mode. Very, very good. You are listening to me, right? No one's giving me number mode. It's proportion, not count mode, right? Proportion. So let's answer the last 4 questions as usual. Let me get the. Did I hear something? Where do you? It's 2025, but still these things. Let me tell you, as a professor, the thing that scares me the most, honestly, is technology. Really, I mean, I'm very comfortable now, but it's still. See, I think that table got copied or some useless thing like that. Okay, so let's answer this. Where's the plot center? Okay, it's not 0.25. Where's the plot center? The plot is now centered. It's still blue. We are 0.2 because the process has shifted. It's a different process now. Where's the red line located? It's located at your observed score, which was 8333. Good. What do the red dots on the right side indicate? They are simulated proportions greater than what you got. And finally, can you answer this question? According to the picture, when you guess on a multiple choice test, you never get anything as good as that because you see, no one could simulate anything more special than that one. So 0% of the time. Good. This is excellent. So we may actually be able to end class early today. Isn't that nice? So Here's a third sheet. Now, this sheet has two sides. So I don't want you to hand this in today. Hand in the early one at the end of class. But this one, I want you to hold on to it because we'll complete the other side on another day. All right. So I'm trying something new because I do teach other math classes, and in the higher classes that I teach, one technique I use is I actually ask students to create their own questions to show me that you understand what you're doing. This is a technique, You write the question yourself, and you will see what I mean when I give this out. So do page 1. Yes, one group gets one. So just pass it to the back, okay? Thank you. Do you see something? There are dash questions on a true-false test. You notice they're still talking about true-false test? I want you to come up with your own question. How many questions on a true-false test did you take? It's a true-false test. That doesn't change. But I let you pick the number of questions. So you discuss with your group. Right? How many questions do you want on your true-false test? You give yourself your result. Right? And then we will have some fun and answer this twice. I want two groups with contrasting results. We will do this twice. So do it on a paper first, then we'll transfer it here. All right. Thank you.
So if this was that,
Yeah.
why is it one up like that?
That's why this exercise is good, because it's always centered at status quo. And the key is the status quo gets
But isn't the status quo the 0.833, which is here?
Point to is what you got on the test. This is always the assumption of I want to know how likely am I to get a score. When I guess on a multiple choice test,
Oh, okay, so we thought that was, so I understand, yes. Also,
the red number is always your actual observation.
yes, and then the status quo.
The status quo depends on the situation.
Right.
That's right.
And, okay,
And that's why this picture is generic. There's no scale.
right,
Although it looks like it's 0.5, I know the picture is a little bit misleading, but
right,
the center is anywhere you want to do.
sure, okay.
Good.
Also, on the homework, I don't have a graphic calculator yet, so I have to do like each one
Oh,
separate.
okay.
So like, if there was like a fraction, I would have to divide it first and write it down. It took a very long time, but I got like 2 wrong at the end of the complicated ones because I was like a couple decimals off, like barely, not too far. Like it was like in the brain because since I had to do it all separately, I had to round it each time instead of just plugging it in all together. So I just kind of wanted to let you know I'm gonna try to get
Okay. You know, I found that there's a TX30. There was of this check that it is 999, but it's not totally good. You really need something that's good. Okay. Something basic like that can do fractions, square roots.
Okay, yeah, but I just wanted to let you know because it's just a little.
Okay, so the advice I need to do all intermediate steps, even if you concept that, is to work with any steps. Then you round only your final answer. So here's what we will do. If you are happy with what you have, and you think that yours is, I know, maybe if your group was adventurous, you try something a bit different outside the box. Then let's have 2 sets of answers. Can I have one? That means we'll fill in the blank now with 2 words. Let's use different colors. Let's use green and orange or something like that. So one group use all green for your answers and one use all orange. So let's have a group that did something unique, right? Something a little bit distant from what I did. Okay, yeah, we can go with that. So there are 10 questions on a true false test. Give me your results, all right? Oh, okay. So to make things faster, let's say you got 8. You see, you're already using shorthand. That's good. 8 correct. All right, good. That's right. And of course, 8 out of 10 is 0.8. That's right. Good. Very good. And the symbol is good. Can I have another group that did something quite different from this? You can use orange. All right, let's put it next to that answer in orange. Right? Oh, yeah, okay, good. Oh, you know what? Can you don't use blue because blue has it's a reserved color for now, right? So something else. No, purple's reserved as well. Orange. That's orange, right? Aren't we in Hope, right? Does it look Hope? It has an orange thing, everything orange, orange. Yeah, okay. You guys, playing it so safe, 20 questions. Okay, and you get 18 correct. No one tried something like you didn't do very well. Okay, never mind.
No, we did.
That's okay. All right. You got 18 correct. That is 0.9. Good. And then
No, I think.
actually this one, the answer is the same, right?
Is there a back?
And oh yeah, these answers, do you realize if it's a true false test and you guess, don't you get about a 50-50 split of CW? Does it matter what you actually saw? Okay, this is important. This is actually not entirely linked to your result, you know. Because I'm saying if you guess, this everyone's answer should be the same here, about 50-50 CW. And if you don't guess, you should get more CW. These answers are universal. It doesn't change. It's not that, oh, my result was better. So that means you don't understand. I'm saying if you guess on a true false test for PC and this is correct, for everyone, this should be the same. Very good. What is the status quo value? 0.5. See, whether you are green or orange, it's always status quo is 0.5 because it is always a true false test. Very good. And the sample size reflects your original test, so 10 or 20, depending on whose answer it was. Very good. So can I see some? Okay, here's a plot. This is perfect. Let me tell you why. Honestly, this is like like the cherry on top. You even have made the box green, right? Okay, good. This is above and beyond what I expected. It's very good. Yeah, it's a nice way to end fast. So we're almost at 0.5. Doesn't change because this is a true false test. See these 10 questions on the test. You got 0.8. You observe. So let's answer those famous 4 questions. Let me copy this one. Then we'll be done. Where is the plot centered and all that? So again, for once, let's not use blue and red color and all that. Let's use green. Where is the plot centered for the green group or the orange group? Because this is a true false test, you are always going to be centered at 0.5. Good. Where's the red line located? Now, this one could use green because the green group had a score of how much? The red line is always located at your observed score, which is 0.8. Good. What do the red dots on the right side indicate? They are simulated proportions that are greater than 0.8. And so it means when you guess, oh, now there's a chance for you to change this. It's more interesting now. When you guess about how many percent of the time, thank you, I think this is the orange groups. Okay, this is still in number mode. Can you convert and then repaste, right? This is correct. It's not wrong. but it's in number mode, right? So for the green group, how many times do you get a score as good as 80% on a true false test when you guess? It's not 0%. Can you see? Do you see that number? This is important. Do you see that number on the screen? You can fill it in. What is the percentage of time that you get scores like 0.8? 4 point, is it? No, it is 4.5%. Yes, right? It is 4.5% because 0.045 is 4. Yeah.
That you estimate is less than 50%, does that change the red line?
Oh, see, no one dared to go there, but someone's asking me a good question. What if, okay, listen to me carefully. What if you did really badly on the test and you got what, 3 out of 10 correct? Where would the red line go? It's still consistent. The red line will be here.
Oh,
You see, but no one went there, so that we will go there next time. But now I think we deal with things that are more intuitive, so we didn't go there. But that's a very good question. All the rules apply. You don't change anything. It's just that you've never seen the red line bounce onto the other side, but you can, you know. I mean, can you get a true false test with 3 correct? Yes. Okay. Here's the orange group. Thank you. So there's an orange. I don't even know how you did that. Monday you had to teach me. All right. So whether you are green or orange, are you centered at 0.5? Yes, because they are doing multiple choice tests. But where's the red line located? For the orange group, it should be located at not 0.8, but you should be sent. Look, the red line is located at 0.9. Why? Because for this group, they got a score of 90% correct on their test, which had how many questions? These are simulated proportions which are greater than, in this case, 0.9. And in their case, did they ever get a simulation greater than 0.9 according to the picture? For them, actually, what is their percentage of simulation? For them, they have a score as good as 0% of the time. Very good. Now, does it make sense to you? Is it quite hard to get a score as good as 90% when you guess on a true false test at 20 questions? Yes. Is it easier to get 80% correct on a true false test when you get a little bit of a yes. So the point is, see, it's easier to do 80% than 90% when you guess. And in fact, this is even harder because this test had how many questions? Actually, this is a perfect vehicle for discussing what's coming up, you know. Is it harder to get 90% right on a true false test with 20 questions than 80% right on a true false test with 10 questions? When you guess. The answer is yes. That is why this happens never when you simulate. So that's perfect. So I think we are all done. Samples, yeah, very good. Thank you. So yeah, so we end class 7 minutes early. So please hold on to that sheet. We will do the other side on Thursday. But please hand in the first sheet that both sides. Thank you. Make sure your names are on the sheet, okay?